So it's very important that you go and take a look to make sure that your GPU, your Nvidia system actually supports the Cuda enabled. So mine happens to be a GTX 1070 with compute capability of 6.1. So make sure your GPU is on this list or one of these lists before you proceed with the rest of the tutorial. Okay, so part of the problem on some of these installers is that if you pick the defaults, you will end up with, well, first of all, I'm going to go ahead and extract that to Cuda temp. Okay, so here's the Nvidia installer, and we're going to go ahead and agree. Click on the advanced. It's not that we're going to change any of the defaults, but we get the added benefit of actually knowing where the install goes. So go ahead and allow the defaults, which is everything. Click next and take a note or a screenshot of where all of this is installed. I think the last I checked, one of these was actually installed in ProgramData. I think they may have actually changed that, but this is just as an added benefit of knowing exactly where you're going to install your toolkit. Now I'm taking a risk by actually recording this because the screen actually will flash a few times while this install is going, so don't get alarmed. I hope it doesn't actually flash while I'm doing this recording. But do keep in mind this installation takes a while, and you may see the screen flicker or even turn off. Yes, make sure you do install the Nvidia display driver. Okay, so at the very end of the install, you will see the Insight Visual Studio components that are installed. So this was kind of a scary message. This just means that I don't have Visual Studio 2013, 12, or 10 installed, and it's actually bothered to locate my 2015 Visual Studio install and put in the additional components. And here you will see that it says it's finished install, and it's installed a newer or same version, so it's really not a big deal. Drivers can be easily rolled back, so don't worry about the driver if you are concerned about the actual version. Just for shits and giggles, I'm going to go ahead and launch both of these just to see what happens. So when I did that, it pulled up the Cuda samples and the Windows open with, which I saw pop up briefly, but then it disappeared. So I'm going to go ahead and do an Alt-Tab to see what happened, where it went. Okay, so my guess is that it didn't do it. I can see that it's created a solutions file, so I'm going to go ahead and, without actually doing any more troubleshooting steps, because when I tried to do this on 2013, it failed miserably. So I'm going to go ahead and select the Visual Studio, and let's see if the solution actually pulls up. So it's loading the project file. You can't see this, but it's Visual Studio on my other monitor is actually loading the solution project. Now it's telling me that their following projects will not be loaded. Okay. Unless I install the Visual C++, let me move this window over so you can actually see what it is. So probably not a good idea to open the project until you've got the rest of the components installed. So I'm going to spend some time to show you some of the default locations where the GPU computing toolkit components are installed. Here, of course, is where the documentation is, and that would be under program files. There, incidentally, you will find under ProgramData, this is where the actual components of the toolkit are installed. Some of the extras, the Visual Studio integration. Let's see what else, as well as some of the other Nvidia components. And the Cuda samples are going to be located here, so you may want to go and change your folder options, folder and search options, to make sure that your folders are not hidden, because usually this one is. The ProgramData folder. So Visual 2015 tools and libraries for Windows Desktop includes the compiler, the CRT, and the Windows 8.1 SDK. So I'm going to go ahead and do that, actually. See what happens. Because now Visual Studio is giving me a window to install the updates. Now I'm going to have to close the solution afterwards anyways, because I got to install the actual Cuda SDK. Well, not the Cuda, but the DirectX SDK. Okay. So at some point it will give you a notification to close Visual Studio. So I'm going to go ahead and close that. You can't see it because it's on my other monitor. And we're going to hit continue. And so these are the these are the components that it claims is needed for the install. So we're going to go ahead and click yes to that and hit update. And it should be noticed that you can read these documents at the developer zone at docs.nvidia.com. This installation guide for Microsoft Windows will also have the information about the Windows operating support and the Visual C++ compilers that are supported. And the interesting that the cross compiler is not supported on the Visual Community 2015. There's no surprise there, but you will have cross compiler support on the Visual Studio 2013 with the C++ 12.0 compiler. The last I did this install, I found that I had to install the DXSDK support. DirectX. So I happened to go in and double check the build customization folder. It actually already has the Cuda 8.0 props, targets, XML, and all of the other content that's needed to go into that folder. So I'm guessing that if you have Visual Studio 2015 installed, and that's professional, not the community edition, all of these things will, if you have that installed prior to installing the Cuda toolkit, it should copy these to this directory. Where did those come from? Well, in the old tutorial for the 7.5, you just simply have to go into the program files, computing toolkit, go into the extras and the integration. Let's see if that's still true. I'm going to go here and GPU, Cuda, 8.0, extras, Visual Studio integration, MS Build extension. So here are the files that if you got the installation out of order, you will want to copy these files into the MS Build Microsoft CPP, whatever version you're operating at the moment, which happens to be, for me, because I'm running 2015 would be. These are sometimes hard to find. You have to keep in mind that some of the components will be installed in either the 32-bit directory or the other. And this is typically the directory where you want to go and copy your build customization. I'll make sure to add these to the to my new instructions. So I'm going to take a moment here to review our environment, make sure that all of the paths, all of the environment variables have been changed. I can see here that Nvidia GPU Computing Toolkit has been added to my path, which is good. I did not add these, by the way. The NvTools extension, Cuda samples root, which is here in ProgramData. In the Cuda samples, 0 root. There is my DXSDK directory. All of this was added when I installed the toolkit. And then the two Cuda paths environment variables. This matches more or less analogous to the same as the 7.5 install. So I did not have to add these, but I do recommend going in and checking these. Incidentally, I'm using one of my favorite tools. It's for editing the environment. It's called Rapid Environment Editor. You can download the installer or the zip file. The one thing I will say that if you need to make changes, make sure that you start it as admin. So we're going to go into the ProgramData toolkit. Let's see. Is it this one? Yeah. Cuda samples. So ProgramData, Nvidia Corporation, Cuda samples, and we're going to go ahead and launch the solution file now and see if everything works. Okay, so it looks like it's pulling everything into its source index. This takes a bit of time. There's Nvidia Insight, which has some interesting additional tools for performance analysis. I'm going to go ahead and switch this over to release. We're going to go ahead and build solution, see what happens. And hope like hell we don't run out of memory. And there we go. Okay, so this takes quite some time. I'm going to go ahead and stop this slide here. Okay, so after spending some time, I decided to go ahead and pick one of the simulations to do a demo, a quick demo. Right now, if you were to go into the solutions file and make sure you have release x64 set, and after you compile, you'll see that 155 succeeded, nothing failed. You'll go and look at the solution samples and drop down into the simulations folder. And take a look at the Nbody CPP file. You'll see that there's a number of bodies is defined as 16384. Recognize that as a power of 2. So, given that this is a pretty small number, and I'd like to see a more spectacular simulation, I looked at some of the powers of 2 that I could plug in that my GPU would be able to sustain. Feel free to use any of these as you want. Just
remember that there is an upper limit, no matter how fast or awesome you think your hardware is.
So I choose 65536. So what you'll need to do in order to locate the binary, and well, that's weird. This is not working. Let's go to Nbody CPP. Well, usually there is a place in here where you can actually open the in Windows Explorer. Instead of doing that, I'm going to go ahead and go to C ProgramData, Nvidia Corporation, Cuda samples. Bin, this is where you want to be. Release. Shift right click. Open up a command window. Type in Nbody. And you'll see the initial demo being loaded here with the default value. It's going to cycle through several settings here on the parameters. What we're going to do is we're going to kill this and we're going to relaunch with a different number of bodies in this simulation. And by doing that, I'm just going to do num devices equals, and the value that we're going to use in this case is 65536. 65536. The reason why we do this is because these GPUs and computers in general tend to be optimized for powers of 2, and the actual I'm not going to go into details about the geometry of the memory. The scalability makes it easier for the system to actually process in terms of powers of 2. So we go ahead and run that. Only one device available. Whoa, that's not the right one. Unfortunately, I picked num bodies is the one I want. Okay, so there we go. So now we have a much finer simulation, which we can stare at. And notice it's running at about 3 teraflops. At some point it's going to cycle through the different settings. And I think they're mostly random. I did turn the velocity scale, velocity dampening down a little bit. Kind of help it. There we go. There's a more interesting. You can click and drag and rotate the simulation. It is a three-dimensional. You can get all sorts of interesting behavior. Sometimes it resembles the Big Bang. Sometimes it resembles galaxies colliding. In a minute, it will cycle to another setting. The parameters. Let's turn this down a little bit. Ah, there we go. Go back to this one. Looks like it defaults at 16.384 as well. So here's that open folder in File Explorer. Go to the top, bin 164 release. We're already there. So it's a quick run through. So particles. So we don't, let's see, doesn't look like we have a way of changing the default value for this one. So let's change it. Let's change it to see 210. That would be 2 to the I for I in range 1 to 40. So we'll use 65536. It's a wonder that I can't remember that. 65536. And we'll go ahead and save it. And we'll build this one. Well, that's obvious. You can't rebuild while you're running the executable. So let's do it again. Now it's generating. Let's go here, upper level, bin. Actually, I think I already have this thing open, so we'll run it. Now we get something that looks like this. We'll use 262144. 62144. And save, build. And here we go. Let's try it again. Now we get something that looks more interesting. Reset random. So we can toggle the sliders and change. You can change the gravity and reset. And I'm going to go ahead and stop the demo there. Demo parameters need more work. If you liked the video, please do click like and feel free to ask any questions if you run into any trouble. Thank you.